This is the last video in the progression of 3. This is chapter 6 in your review packet. So once again, I'm just going to go through the questions individually, so watch the ones that you have a question on. So first one, we're going to take the square root of 49x squared y to the 10th. So square root of 49 is 7. Square root of x squared, or how many groups of 2 there are in x squared, is just plain old x. And then how many perfect squares are there in y to the 10th, y to the 5th. It's okay to have a negative under this root because the index is odd. We're taking the cubed root. So the cubed root of negative 64 is 4. And of course you can tree it as well, and you'll see that you get lots of 2's in there. So you take out 2 groups of 2. And how many groups of 3 are there in y to the 9th? Well, there are 3 groups of 3. The 5th root of 243. So in my calculator, I would check that. So remember, you can press a 5 in your home screen. Then you go to the math button. And number 5 is the x root. So you'll select that one and you type in 243. And that one actually works out nicely. And you get a 3 for the 5th root of 243. How many groups of 5 are there next to the 15th? Well, there are 3 groups of 5. If it's not a perfect root, then you're going to go ahead and tree it and look for those groups. Multiply, in this case we have 2 binomials, so we're going to go ahead and FOIL. So 7 times 1, those are our first, we get 7. The outers, 7 times root 5, we get 7 root 5. The inners, we get 1 times root 5. And the last one's 5, or root 5 times root 5 is root 25, which is 5. And now we just combine our like terms. So 7 and 5 gives us 12. 7 root 5 and 1 root 5 gives us 8 root 5, and we can't combine them any further because now they're not like terms. Number 5, we're also going to FOIL. So 6 plus root 10 squared is really 6 plus root 10 times 6 plus root 10, and we're going to FOIL again. So 6 times 6 is 36. 6 root 10 and 6 root 10 gives us 12 root 10, and root 10 and root 10 is root 100, so, or just 10. So we get 46 plus 12 root 10. And then same thing on the last one. Or actually, just to back up to number 5, sometimes you guys want to change these signs. You're not supposed to change the signs. If you're squaring it, you're multiplying it by itself. So they should both be pluses. Okay, number 6. So now we're going to go ahead and FOIL. So 5 times 2 is 10. 5 times negative root 3 is negative 5 root 3. The inners, 2 root 3, and then root 3 times root 3, but it's negative, is going to be 3. So 10 minus 3 is 7. Negative 5 and 2 gives us negative 3 root 3. For the next 3, what I would do is go ahead and just plug it into the calculator. And when you plug it into the calculator, just verify that you get the same things that I got. So this one is 9, this one is 125, and this one is 8. So just always plug it in, see if it works first, and then if not, then you want to tree it. For this one though, you would want to go through and put it back. Remember that a rational number is the same as a radical. So this would be the cubed root of 27 squared, and then you would have to square 27 and tree it. So always check the calculator first to save yourselves a little bit of time. Okay, here we have a power to a power, so in that case we multiply the exponents. So negative 2 times 3 halves is negative 3, so we get x to the negative third. But since that's an unhappy exponent, we got to make it happy, so we kick it to the bottom. Once again, we have a power to a power, so we multiply the exponents. The 3's cancel and the 4's cancel, so we just get x, because it would be x to the first. Same thing, power to a power. You just have to make sure that that 16 on the outside goes to both the negative 3/8 and also to the 1/4. So negative 3/8 times 16 is negative 6. So we get x to the negative 6th, and 1/4 of 16 is 4. So we get y to the 4th. So that's your final answer, or that's not your final answer yet, because the x to the 6th is not happy. The y to the 4th is though. So the y to the 4th stays where it is at, but the x to the 6th goes to the bottom in order to be happy. Okay, now a couple solvings. Recently we just did this on the calculator, so here we'll just do it algebraically. So in order to get rid of the root is by itself, so that's good. So we're going to go ahead and square both sides. So when we square both sides, we get 2x plus 1 equals 25. Subtract 1, and then divide by 2. So we get x equals 12, and then plug it in just to make sure it's all good. So 2 times 12 is 24, plus 1 is 25, square root of 25 is 5, so x equals 12. For number 14, I would suggest writing it as a radical so that you don't forget any second answers, because sometimes we get two answers in these. So here we get the fourth root of x plus 6 cubed equals 8. So first you're going to raise that to the fourth power. So we get 8 to the fourth equals x plus 6 cubed. This is going to be a positive number, so that when we take the cubed root, it's also going to be positive. So then we'll have x plus 6 equals the cubed root of 8 to the fourth. So I'm going to plug in 8 to the fourth into my calculator. I get 4,096, and then I'm going to take the cubed root of that, also using my calculator, and we get 16. So x plus 6 equals 16, so x equals 10, and you're done. And then just plug it back in to make sure that you did a good job. Last but not least, if we see a radical, this one we can't tell what the transformations would be if the graph of the parent function just root x. So in order to see the transformations, we just need to get x by itself. So we need to get rid of that 16. So we factor out a 16, and we're left with x minus 2. If we were to break this down, we get root 16 and root x minus 2. We know the square root of 16 is 4, and then we have root x minus 2. So now we can see that this one goes right to and has a vertical stretch of 4. So if we were to graph this, we would get an ordered pair at 2, 0. And then if we were to plug in 3, we would have an ordered pair all the way up at 4. And then we would get a graph that looks something like that. So those are the 3 videos. On Monday, we'll wrap up any last review. Have a good weekend.